Hi everyone, now I want to continue my discussion of data science roadmap. This is the 8th part. This is one of the most important part of data science or machine learning. Engineering and scientists is deploying a model to production. Alright, so there are many ways you can deploy a model to production. Deploying model to production means what? When you develop your model, you develop it inside a Jupyter notebook, inside a development environment. Production is different. You want everyone to see your result. All the stakeholders or customer are be able to see your findings, your model, the result of your model. That's what deploying to production means. Alright? So this is heavily different from development environment. Alright, let's see what we need to do to deploy model to production. So usually in machine learning, we have a development phase. We call it dev. During the development phase, we have a code that reside in notebook, reside in IDE or notebook. Development phase is not version correctly, not version. Remember I talked about data versioning? We don't version data. We don't really version the model. We just practice. We just practice / R&D work, research and development. It's a research, right? We're researching to see what's the best hyperparameters, whether this model is good or not, all right? And the most important one is that the code and the tools are not efficient and reliable. Scale. This is the most important thing you need to know. The code that is in development phase might have an infinite loop, might have a very high time complexity or a space complexity, might take forever to run. When you go to production, you have to avoid this because the resources are expensive. The tools that you are using, you may use R for development. When you go to production, you want to write this in Python. All right, so that's the development phase. We want to move from this to the production phase. Means that everything is efficient and runs on the best practices. That's what the whole purpose of MLOps. If you remember, putting a code or model in production reliably and efficiently. All right. So what's the first step that we are doing? We are gonna start with this. All right. We're gonna write the codes and tools that are efficient and reliable and scalable. Let's see what we need to do. So step one for deploying model to production, step one would be convert a code base to production ready code. What does it mean? 1. Object-oriented design. Use efficient data structure. Efficient data structure. And what I mean by that, I mean like dictionary, NumPy array, etc. Right? Use efficient data structure. Use or rewrite the code using efficient algorithm. Rewrite the code using an efficient algorithm. If you have recursion in your Jupyter notebook, you want to convert it to dynamic programming. You don't want to write loops after loops after loops, two for loops inside each other. Maybe you can use two pointer, right? Algorithm and data structure. Now you will see that why they are very important for a machine learning engineer or software engineer. And then object-oriented design. something reusable package. We don't want to copy and paste a function 100 times. Reusable package. It should be all callable. All right. And now something I didn't talk about that. Unit testing for all functions. We want to write unit tests to see whether the functions are correctly implemented or not. Are they doing what they are supposed to do or not? So this is super important, unit testing. I think one of the videos I talk about that, using PyTest and unit test package in Python. Alright, but this is very, very important. That's the first step. You convert the code. In development phase, you don't write a unit test. In a production domain, you must have a unit test. You must absolutely have a unit test, otherwise you cannot put the model in production. Alright, so that's the first step. Alright, so now let me tell you a little bit more actually. What should be the structure here? Typically, what should be the structure? The structure is that a class for feature engineering, a class, object-oriented class for modeling, class for evaluation, and class for explainable AI, perhaps, or interpretability. Alright? Usually you want to write it like this. Different multiple classes. Okay? I talked about this some in my videos before. Alright. So that's the first step. Now that you have a code in a production ready environment, now you need to ask yourself that how this code should run. So step one was that converted to production level ready stage. Step two, how are we gonna run this code? How are this code run? Right? And the answer to that is that in a production environment, no one has access to a notebook, click on run and then stop and start again. A scheduled frequent job for training and prediction. After you perform all this production level code base, you need to be able to run your code on a frequent cadence, right? Therefore, you have to schedule a job that the training is done always on Saturday and the prediction is always doing on Sunday, something like this. You need to automate this process. I will tell you what tools you can use for that, but this is a step two. All right. Now, after we are done with this step, of course, we need to have the schedule job to update our tables, update our database. Right? This is very important. All right. So now that we have a scheduled job, then we need to have a monitoring. You cannot put a code in production without monitoring that. Okay. So the code needs to be monitored. Monitoring and dashboarding. I talked about this. Right? So once you schedule a job, the results are available in some sort of tables, dashboard. You need to be able to monitor to see if there is any data drift, if there is any change to your model. Right? Therefore, we need to be able to have, in case of change, we need to, what do we need to do? In case of change, we need to version data model. Right? We need to version the data model. Monitor that, we realize our data has a problem. Alright, we didn't impute it back. That was version 1. We started version 2, version 3 for the data. right? For a model, the model did really bad. The model did bad in the August, in July. September is really bad. Okay, go back, go back, go back. We need to start doing versioning of the model. That was V1, now we go to V2. This is part of production. In development, you don't really do that. In production, you do it, okay? Then next time, this circle continues. It's a circular thing. Next time, when you switch to V2 version, then you have to run the schedule job as well, all right? Great. Now I'm going to talk about the how you actually productionize that. What tools you are using that. What tools you need to know about that. All right. The tools that you need to know, I try to write what are the state of the art tools. There are a lot of stuff out there. Like I've seen people use Flask and Django for putting the code in production. That's not really a standard and it's not really scalable. All right. So tools for productionizing ML model. Alright, so the tool that we are going to use for the productionizing a code, you can use VS Code or PyCharm, these are my, or Sublime Text. To transfer your code in Jupyter Notebook to classes, to object oriented. With Flake8, or Pylint as an inter. Alright? Flake8 or Pylint as an inter. To tell you, for example, about any mistakes that you have or any errors that you get, for example, or any spacing. We want the code to be PEP8 standards, but we haven't talked about that. This makes the video actually very long. Alright. Another one is the GitHub or some version control. Alright. This version control is about the version that I'm talking about. Everything should be in GitHub. Every single thing. Everything you do, you should commit it to GitHub. You use it, you open a PR, pull request, people review your code, you push it to production. Everything should be in the form of GitHub or any some sort of version control. After this, now we have the code in a production level environment. There is one more tool is left for the large data or distributed analysis. PySpark, Spark SQL, Scala. For a large data or distributed data analysis. Alright? I would write horrible tool as well. If you're not familiar with horrible, let me know. I can actually make a video. Horrible is distributed training and distributed prediction for larger scale analysis. But these are the tools actually used for the big data. If you cannot load the data to single memory like Python, you use PySpark because it's a lazy evaluation. It doesn't load it into memory. Alright? Now you have all these tools available. Productionizing a code, doing version control, what people call CI/CD, I haven't talked about that. And then PySpark for the big data. We get to the most important part. What technology do you use? What technology you need? And what the technology for the actual running your code in production? What technology you need to run your code? Your code cannot run on the GitHub or cannot run on the VS Code. Cannot run on your local computer. Cloud technology. You can know AWS, Azure, Google Cloud. Right? AWS, Azure, Google Cloud. I'm not going to talk about each one in detail. You can use SageMaker, EMR, Elastic MapReduce, or big data stuff. But SageMaker for productionizing your Python code, you can create a checkpoint. For now, we leave it as it is. Azure ML, you can use equivalent to SageMaker. Google Cloud platform. Google Cloud is equivalent to SageMaker. you use this cloud technology, you can either use AWS with a combination of SageMaker, for example, for running your Python code, EMR for running your PySpark code, right? Redshift, I just want to tell you how strong is AWS. Redshift for your database stuff, or Azure, you can do the same thing with Google Cloud, Google Cloud Platform, or you can use either of this technology and then use Databricks. So you have your cloud as Databricks, as AWS, but then Databricks will act like your SageMaker notebook. It will be like a notebook, like SageMaker. Right. In that case, if you decide to use Databricks, and if you don't want to use AWS besides anything like a cloud to create a cluster for you, you can just use AWS or Azure or Google Cloud as the cluster. Then you can use your own database. Database, you can use a Snowflake. You can use Microsoft Server. You can use MySQL, it's barely used in practice. Okay. This is for the actual cloud technology, or where your code is actually running. All is all good. One more thing I want to tell you is that, what's my suggestion, or what is my favorite thing? You don't have to follow this, but this is my favorite. It's used a lot. You can use AWS with the SageMaker and EMR and Redshift. They work perfect with each other. Amazing. They're amazing. They do everything you like. Database, big data, all the machine learning models you have. If you don't want to, you can use AWS and Databricks. Okay, in that case, you don't need SageMaker and EMR. Databricks is very good actually with the big data. It has an inherent support for the Spark, right? And then for the Redshift, you can actually go back and use Snowflake or Microsoft Server. So these two are my favorites. Either this one completely or this one and Databricks. All right, this is actually kind of a long video. It might be a little bit too much of information. If you have any question about any of this concept, let me know. Leave a comment. I do my best to answer your questions. And I will see you all in the next video. Thank you.